In this video, I'm going to look at an HTML page with an SVG element that has JavaScript generating a dynamic SVG design based on the artist Vasarely, Victor Vasarely's Vega. So here, that was the that's the sort of, he's done a number of these type of things. This is one of them at Buffalo. And here is mine. The overall design is less complicated, but I've got some time dependence. I've got the colors changing in time, so I'll show you how I've done that. Okay. So here is the sort of it's almost all JavaScript. Here's a little bit of style. Here's an empty SVG, and then it's almost all JavaScript. Let's look briefly at the style. Centering it, I'm using a variable that is sort of half of the size of the design. So I'm going to work sort of from the center. So this is having a variable of the half size is going to be useful to me. And then here's my styling of the SVG, giving it a width and a height, where I'm using var to get the value, which is 300 pixels. And then I'm multiplying it by 2 to get 600. And I'm making that my width and height. So there we go. So that is the style. There is the SVG. Now let's start looking at the code. So I'm going to be creating elements, SVG elements. I think they are, strictly speaking, XML. Sort of the SVG container itself is an HTML tag, but I think what goes inside is more XML. So it's not part of the sort of standard language, so I have to expand the namespace a bit to get to work with create element, as we'll see below. A number of constants and variables. I have a variable for the sort of number of divisions. So sort of starting at the center, and I'm going to have sort of 10 divisions. So overall it's going to be sort of 20 by 20, but this is sort of, I work in quadrants. So everything is going to be sort of, I'm going to do something in sort of this quadrant and then duplicate it in the other quadrants. So that's the number of divisions in a quadrant. This is the sort of maximum fraction that is going to be spherical. So the most spherical gets us to be sort of 82%. So I'm not going all the way to the edge. I'm not going to 100%. I've got a timer, so I have a timer ID. I don't really need the timer ID unless I'm going to stop the timer, which I don't, but there you have it. Within the colors, I'm working within style. I'm working within the HSL color scheme. So instead of the normal sort of RGB for web pages, I'm working within hue, saturation, and I think lightness. And so Vasarely's work is normally fairly bright, so I wanted to change the colors, but keep fairly bright, fairly high, like saturation value. I shouldn't say bright, I should say saturation. That's what I mean. He works fairly saturated. So I wanted to have work in that color scheme so I could sort of stay fairly saturated. The other thing useful about that scheme is that I'm going to vary the hues. So the hues are going to be in HSL are a amount of like an angle. So the angle is like you're going around a circle 360 degrees. So I'm going to have two hues. I just started them at 20 and 240. I'm going to change them as we go. You can see the sort of colors changing. And I'm going to change them by different amounts. So they're not going to they're not, it's that difference between the two hues is not going to remain fixed. So at some point, if you let the design go long enough, there'll be times when the hues are the same or very slightly different. And I have a time. So I am, I, I have in style, I have this half size variable, but it's also useful to me to have a version of it in JavaScript. So that's what this M is. So I'm just getting the value, stripping off the units. And so that's that 300. I am starting my timer and calling a function Vega, and I'm calling it every 33 milliseconds. So I could make it go faster or slower if I want, just by changing the 33. I'm not sure how fast I can get it to go. It depends on like the efficiency of my computer and how long it takes it to generate all these these polygons. Okay, I have an array of points, so I'm going to, when this is these are going to be some kind of quadrilateral, but in SVG, they're going to be polygons. And so I need a set of points, and each point is an X, Y. So this is going to be a set of X, the set of X's and a set of Y's. And then I have a grid. So sort of each quadrilateral is four XY points. And so I have a two-dimensional array of X's and a two-dimensional array of Y's. That's what this is. And I'm just sort of setting that up at first just with sort of zeros. And so I declare them as arrays, and then I loop over and push onto them. So this here, new array, num plus one fill, is making an array, and then I'm pushing that array onto my array X. And so I have an array of arrays. I have a two-dimensional array. Okay. And that's outside of Vega. So I'm just sort of establishing that I have this array. Now here I am in the Vega function. This is the function called by the timer. I'm clearing out anything in Vega that I previously had. I'm changing my time. And again, this is another way that I can control the speed if I want, by changing the amount by which I'm incrementing time. Here I am changing the hue 1 and hue 2 so that this is my colors sort of evolving, and I am dividing by 360 and taking the remainder. I'm using the modulus function here because, again, the hue in the HSL color scheme, the hue is an angle in degrees. Okay. So this is the amount of, this is sort of the radius of the circle, and I've made it a function of t. And so you see cosine varies between 1 and -1. So when it's 1, it's 1 plus 1 divided by 2. Z, I told you before, was that percentage of thing, and num was the number of divisions. So this is sort of a number of divisions that are included in the spherical part. And I have that again as a function of time. So it's very large and then goes down to 0. So, and it's oscillating. So that's what the cosine is doing for me. The radius of my sphere is sort of oscillating 0 to my max and back. I'm going to talk about y log, but this factor f is I have sort of within the circle and outside the circle, and I need them to sort of like match up. And so this f scale, I'm going to have something to do with the log of r plus 1 internally, and this factor f is to sort of scale it or help me sort of match up the inside and the outside of my design. Okay. I am making my two-dimensional lattice. So, and then I'm going to sort of rotate it and use it 4 times in my 4 different quadrants. But here I'm making my x and set of x and y points. And so I'm looping, going from 0 up to and including num, and doing the same thing for j. So I have this nested loop. I am making a radius, an r. How far am I? Square root of I squared plus j squared. How far am I from the center, from 0, 0? And then if I am inside the circle, where again inside this circle, I do something different than if I'm outside the circle. Outside the circle, I'm just doing my x is I and my y is j. M was that size, that sort of 300 for me, divided by num. So I'm taking 300, dividing it by num, which was 10. So I have 30s. And so when if I'm outside the circle, then these are separated by 30s, the i's and the j's. Okay. Inside the circle, I'm using this function. There's that f, that scaling thing. And I have log of r plus 1 times I on r. Now, I on r, that's, if you've had, I don't know, physics, general physics or anything like that, that acts like a cosine, and it takes the horizontal component. So I have something and I take the horizontal component of it. J on r is like a sine. It takes the vertical component. And so now I have this log of r on 1. So y log of r plus 1. I don't have like a completely fine explanation, but I can explain a little bit, some basics of it for you. You see, when as I come out from in the circle, I always want, as I and j increase, as r increases, I want it to always be increasing. I don't want my quadrilaterals to start going back or anything like that. So I want a function that, as a function of distance of r, is always increasing. But you see, these early ones are bigger than the later ones. And so I need the sort of the change, or the derivative, if you will, to be decreasing. So I want the function to be increasing, but the derivatives to be, or the changes to be decreasing. And so that, in sort of fairly simple functions, one candidate for that is log, and that's what we do use here. So here is just a graph in Excel of that function, r log of r plus 1 versus r, and then we see that it's always increasing, but that its change, its slope, is decreasing. We could also just have, if that's the only behavior we needed, we could have also had sort of some power, r to some power, and that power being less than 1. That would also have this increasing but derivative decreasing kind of property. Okay. Anyway, so there we go. So this f scaling to match up with the lattice behind, this log behavior of it always increasing, but the space between them, the derivative decreasing, and then take horizontal component for the x's, vertical component for the y's. So that's enough, or as much explanation as you're going to get out of me here for this math. Okay. And if I'm outside of the circle, just a normal lattice. Okay. So those are my x and y points. Now I have to turn them into quadrilaterals. So I was having trouble getting the 0, 0 point correct. And so then I ended up just hard coding it here. Okay. So now here we are just looping over all of my I and j. I'm starting I and j at 1 rather than at 0, but I'm going to take points where I'm subtracting, I minus 1 or j minus 1. So that's why these don't start at 0. I have a nested loop, so I'm going over all of my points. I am setting these two colors using the HSL scheme. And then here is this something based on H, and I have I plus J. So I'm adding two I and J. I'm adding two numbers. I'm dividing them by 2. So that's either 0 or 1. So then I'm multiplying H2 minus 1 either by 0 or 1. So if I multiply it by 0, I have H1. If I have H1 plus H2 minus H1 and it's multiplied by 1, then the H1s cancel and I have H2. So this oscillates between H1 and H2 depending on I and J, whether I plus J is even or odd. That's the checkerboard pattern. I kept my saturation at 80, so fairly saturated, not completely saturated. And then I have a lightness and the L in HSL, and I have it starting when I and J are 0, starting off at 80, and then as I and J increase, then I am subtracting, so I'm getting a bit darker, and that's giving me this sort of light in the middle and dark at the edges. And then I have two colors. The other color is just different by the I and J. So here, I plus J divided by 2. Here I have I plus J plus 1 divided by 2. And that is when I work in my different quadrants. I had to work with the 2 of the quadrants. I work with color 1, and the other one when I work with color 2. Okay. So here is my lower right. So when we are making a design in any sort of computer, then you work from top to bottom and from left to right. So I am here taking M, which is sort of my center, and if I'm adding, then I am going, if horizontally, I'm going to the right, and if I'm adding vertically, I'm going down. So this gave me the lower right because M was my center, and I'm adding the X's and adding the Y's. And I added the point X minus 1, J minus 1, X and Y, I and J minus 1, IJ, and I minus 1J. So these are all the sort of points near each other to make a quadrilateral, which is just a particular polygon. In the XML within SVG, the polygon wants a variable or a property called points, and it wants X and Y separated by commas, and then XY pairs separated by space. So this is me building up my points and setting my points to be the points of this polynomial. I made the fill color 1. I played around with some strokes, but I got rid of them in the end. And then I added that quadrilateral, that polygon. If I subtract them both, then I'm in the upper left. Subtracting in horizontally moves me to the left. Subtracting in the Y moves me up. So that was the upper left. Same thing, except gives me a different quadrilateral. Here I'm subtracting the x's and adding the y's, so that was the lower left. And again, I worked with my shifted color because this quadrant, sort of, you look just at the center and just think about it. That first quadrilateral, you in the the upper right and the lower left are the same, but I wanted the color flipped for those other two quadrants. So that's why switching color 1 and color 2. And this was lower left. And then finally, same deal, but upper right. So I'm adding the x's, so that's moving me to the right. I'm subtracting the y's, that's moving me up. And there we have it, that sort of oscillating or breathing Vega design, moving through the different hues. Right now, the colors are sort of blue and green. The hues have gotten perhaps a little bit closer than where they initially started. And that's what I wanted to show you here. Thanks for your attention.